guys, so math is all about patterns. So what we're going to be doing in the next couple of lessons is trying to point out some patterns that will help make factoring easier. This is going to be for very specific cases. So the first one is going to be difference of squares. Let's get right to it. All right, guys, so lesson 3A-5 is going to be focusing on a special case of factoring. We're going to be factoring the difference of squares. So the difference of squares we're going to define right here. So let's take a moment real quick and go to the glossary and put this definition in. So a difference of two squares is a squared, meaning multiplied by itself, number subtracted from another squared number. So that's where the difference comes in, that subtraction. It refers to this identity, a squared minus b squared becomes a plus b times a minus b when you factor. And we're going to practice this little identity right here. That's going to be the whole focus of this lesson. So our learning target for this lesson is that we can factor the difference of two squares. Kind of said that about 5 times already. So the difference of two squares has the form a squared minus b squared, which again, I've already said a little bit, a squared minus b squared. A polynomial is a difference of squares if there are two terms, one subtracted from the other, and both terms are perfect squares. Now, I made a little note over here in your notes that a term is considered a perfect square when it's the product of another number and itself. So 4 is a perfect square because it is 2 times 2 or 2 squared. X squared is a perfect square because it is x times x. So it's perfectly simplified. 9y squared is a perfect square because that would be 3y times 3y, or 3y squared. Okay, so all of those are examples of perfect squares, and you're going to get really good at recognizing those as we go through some examples of factoring differences of squares. So what you're going to do with each of these is you are going to identify what your A term is and what your B term is, and then you're going to use this rule to factor it. So as with every other factoring problem, the first thing you need to do is look to see if you have a GCF, or a greatest common factor. When I look at 8 and 18, those are both, right now, this is not a perfect square because 8 doesn't break up into an easy 2 times 2 or 3 times 3 or anything like that. Neither does 18. So I'm going to see if I can factor out something. Well, both of these are even, so that means we can factor out a 2. So I'm going to pull out a 2, and what that gives me then, 8x squared divided by 2 is 4x squared, minus 18 divided by 2 is 9. Now I have a difference of squares, because now 4 is 2 times 2, and x squared is x times x. That means I have 2x squared minus, and then 9 is 3 times 3, so minus 3 squared. So remember, your rule is that you're looking for the base that's being squared minus the second base that's being squared, and these are the values that are going to get factored. So I'm going to have my little shell, and I know that my first one's going to have subtraction and my second one's going to have addition, and I need to identify what that A and what that B are. Well, writing it this way makes that super duper easy. I'm going to switch to highlighter. So my A is going to be 2x. So that means that I'm going to put A, that 2x, here, and I'm going to put it here. Then my B is going to be 3, because the thing that's being squared in the second spot is just that 3. Not the 3 squared, not the 9, just the 3. So you're taking basically the square root of each of these, and that's what goes in your 2 blanks. So let's do 3. I don't know why it's back to thick this time, and 3. And you can check yourself to make sure this works. 2x times 2x is 4x squared. 2x times 3 is 6x. Negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. Well, 6x and negative 6x are 0. So now I've got my 4x squared minus 9. Please remember that that 2 that we factored out at the beginning should still be there at the end. So remember, there's still a 2 being multiplied there. So then my final answer that I'm boxing in is 2 times 2x minus 3 times 2x plus 3. All right, let's go to another one. So on this one, I am again going to start with my shells. I'm going to check to see if anything can be factored out. This is 3 and 3. 16 is nothing but 2's when you get the prime factorization. And then I've got completely different variables. So there's no GCF that needs to be factored out. I'm going to think about what is the square root of each of these. Well, 9, square root of 9 is 3. Square root of p to the 4th, that's 4 p's, which means the square root of it would be p squared. So let me just give myself a little bit more room and show you what I mean by that. If I take the square root, if I do the prime factorization of p to the 4th, I end up with p times p times p. Remember that what we're trying to do is break it into something that's being multiplied by itself. So that would be p squared times p squared. Remember that when you multiply terms, you add those exponents. So that is equal to p to the 4th. So anytime you see a variable with an even number, really you're just cutting it in half. That's what taking the square root is going to be. So that means that I've got 3p squared, and that's what's being squared, minus square root of 16 is 4, square root of q squared is q, and that's what's being squared. If you want to check to make sure I'm not lying, remember you would distribute this exponent. 3 squared is 9, p squared is 4, because you would say 2 times 2, so that's 4. And then here, 4 squared is 16, and q squared is q squared, so that's equal. Now I can find my a and my b. So a is going to be 3p squared. B is going to be 4q. So remember, I'm putting my a's in the first spots. I'm putting my b's in the second spots. And there should be a subtraction first and then an addition. Really, it doesn't matter which one ends up being subtraction and which one's addition, but just make sure that you've got one of each, because that's what makes that canceling of the middle terms happen. Okay, so I'm putting in 3p in both of the first spots and 3p squared, and 4q in both of the second spots. And that's my final answer. Again, just to help you check yourself, 3p squared times 3p squared is going to be 9p to the 4th. 3p squared times 4q is going to be positive 12p squared q. Negative 4q times 3p squared is going to be negative 12p squared times q. And then negative 4q times positive 4q is going to be negative 16q squared. Again, positive 12 and negative 12 cancel, and I'm left with 9 times p to the 4th minus 16 times q squared, which is what you get here. That's the last time I'll check my answer, but I just wanted you guys to see why this process works the way it does. Okay, so in example 3, again, first we check for a GCF. There is none. So then I check to see if each term is a perfect square. X to the 6th is, that would be x cubed squared, because 2 times 3 is 6. Over here, though, 7 is not a perfect square, which means I can't write my nice pretty term here with the perfect square. So this is not a difference of squares. So we would just say not a difference of squares. And there's not really a lot we can do with this at this point. So you would just have to leave it there. All right, so moving on to example 1. Again, no GCF, but I can take the square root. Be careful with 1 because we're used to thinking of 1 as, I can't do a prime factorization. It's already there. But the square root of 1 is 1. So you could have 1 squared and it's still a perfect square. Over here, if we take the square root of 25 and k8, square root of 25 is 5. Square root of k to the 8 is k to the 4th. So there's my second term. Okay? Now I'm ready to start filling in the blanks. I've got my minus, I've got my plus. Remember, we are identifying our A term. In this case, that's going to be 1, so it's going to go in both of these spots. And my B term, in this case, is going to be 5 times k to the 4th, and that's going to go in these 2 spots. So then my final answer is going to be 1 minus 5 times k to the 4th times 1 plus 5 times k to the 4th. And that's it. All right, go ahead and do some practice and let us know if you have any questions.